All right, we're back to they give us the name and we draw the picture. Now, the main instructions on this page say draw a condensed structural formula, the one with the CH's and the C's and H's, and right under that, because I forgot to erase it, it also says draw the line structural formulas. So, as penance for my crime, I will do both. When I read this, I see blah 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 hexane, which is, oops, beautiful color there. 1, 2, 3, 4, 5, 6. On the third carbon, put an ethyl group. And on the second and fourth carbons, put methyl groups. Some of these should be above the line, but I don't have space, so I'm cheating. All right, so that takes care of all of our branches. And then if we hydrogen this, tedious but necessary, CH, this is a three-way intersection. Three-way, 2 there, so 2 rooms for hydrogens, and only 1 bond here, so it's 3 spaces for hydrogen. That'll be CH3, CH2, CH3, CH3. All right, now, I did this straight just to show you that that's okay for a condensed structural. If you're doing line structural, you cannot do straight lines, because if you go 1, 2, 3, 4, 5, 6, no one can read that. No one can tell how many carbons that's supposed to be. So when you go line structural, it is mandatory to zigzag them. You have to go, there's 1 carbon, 2, 3, 4, 5, 6. There is hexane. On the third carbon, put an ethyl group. 1, 2, bend that also. On the second carbon, put a methyl group. Pop. On the fourth, put a methyl group. Pop. That's all you need. No letters in this unless you've got an O or something unexpected. Otherwise, every intersection defaults to a carbon covered in hydrogen. Blah, 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 decane. This is going to be tedious to do the hydrogen on. 4, 5, 6, 7, 8, 9, 10. All right. The fifth carbon there gets a butyl group. That's 4 carbons. 1, 2, 3, 4. The second and fifth carbons get methyl groups. There and there. And I really want to duck out on doing all these hydrogens, but I will try to show some fortitude. CH2, 4 bonds there, no room. CH3. All along a chain like this, you get CH2s, and the terminal carbon is a CH3. CH2, 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 and on the end, of course, CH3. If we do this with line structure, the decane will look like, there's your first carbon, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fifth carbon, 1, 2, 3, 4, 5, gets a butyl group, 1, 2, 3, 4. Second and fifth carbons get 3, 4, 5, methyl groups. Something like that. Okay. Now, can I fit this thing? It's a nonane. I'm going to get a little cramped. Okay. Nonane, 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. On the fourth and sixth carbons, put ethyl groups. Sorry for the crowding. On the second, third, and sixth carbons, put methyl groups. There's 1, there's 1, and because I already went up there, gotta go down. Yeah, okay, so that's the whole structure. We got a nonane, it's got 2 ethyl branches, it's got 3 methyl branches, and now we spent a long time writing hydrogens. 3 on the ends. All these terminal ones are going to be CH3s. If you want to go around like this and do all the outermost carbons as CH3s, that is all right. all the ones in the middle of a chain like this are going to be CH2s. Sorry, we'll try to keep that legible-ish. CH2. And if you're on an intersection, then you have to count carefully. 3 bonds used, 1 left. 3 bonds used, 1 left. 3 bonds used, 1 left. 4 bonds used, none left. And I forgot these. That's a CH2. That's a CH2. Hand cramping. That's it. That should be it. Line structure. There's your first carbon. 2, 3, 4, 5, 6, 7, 8, 9. Fourth carbon gets an ethyl group. Sixth carbon gets an ethyl group. Second carbon gets a methyl. Third carbon gets a methyl. And 4, 5, 6 gets a methyl. Nothing to it. They go really quick with the line structures. You can see why people like those. And they actually let up on us for the very last one. 4-propylheptane. Heptane is 7. 1, 2, 3, 4, 5, 6, 7. On the fourth carbon, there, put a propyl group, which is 3 carbons. 1, 2, hurting for space. And now we do hydrogen. 3 bonds used, 1 left. 2 bonds used, 2 left. 2 bonds used, 2 left. 1 bond used, 3 left. 2 bonds used, 2 left. 2 bonds used, 2 left. 1 bond used, 3 left. And in line form, a heptane looks like there's your first carbon. 2, 3, 4, 5, 6, 7. Last chance to remind you, please don't look at hept and think I'm drawing 7 lines. You're not. The first carbon's here, and then look, 1 line, 2 lines, 3, 4, 5. You only draw 6 lines. This, you draw the first carbon just by starting a line, and then every line you draw adds another. So 7 carbons, 6 lines. The way I do it is just draw a dot for the first one, and then I count. If this is the first carbon, 2, 3, 4, 5, 6, 7. But don't think this tells you the number of lines to draw, or terrible things will happen to you. Now on the fourth carbon, 1, 2, 3, 4, put a propyl group, which is 3 carbons. 1, 2, 3. Does it have to go that way? No. You could angle this way. You could angle off in some cockeyed direction. We'll get into molecular shape in a big way in later chem courses, but for now, as long as you're showing the correct number of bends and you have 1, 2, 3 carbons in this branch, you are doing fine.